There are many different types of information systems, and as auditors, we need to be familiar with these types so that we can audit them effectively. Let's start with understanding the various types of information systems and systems architecture being used today. One of the most common that we hear about is virtualization, and virtualization is a tremendous tool. It enables us to take one single physical hardware device, a computing environment, and on top of that, we can run a number of different types of independent systems, so it's as if we have 3 or 4 different computers on one. So what are the elements that make up virtual systems? Well, you still need the physical hardware, the platform that everything will run on. But on top of that now, we're going to insert something known as the hypervisor. The hypervisor enables us to then run different types of guest environments or virtual environments onto that physical hardware. So that now we can run, say, several different types of guest environments through that hypervisor on one piece of equipment. This really makes it such that we can be running different operating systems, completely different environments on that physical hardware. There are 2 main types of virtualization. There's what we call bare metal. And this is where the hypervisor is running directly on and interfaces with the physical hardware itself. The guest operating systems then run on top of the hypervisor. And then the applications on top of then the guest operating systems. This would be contrasted with a hosted virtualization implementation. Now, we have the physical hardware and it has its own host operating system that's running on it. Then on top of that host operating system, we run then the hypervisor. The guest operating systems then run on the hypervisor and of course the applications on those guest operating systems. So the difference between the two is, where is the hypervisor? Is the hypervisor directly connected or communicating with the physical hardware? Or is it that the host operating system communicates with the physical hardware and then it hosts then the actual, should we say, hypervisor itself on that operating system? There are, of course, a number of risks associated with virtualization, just as there are, of course, many different benefits. The hypervisor itself is one more attack surface. There's always the risk that any problems of vulnerabilities within the hypervisor is something that is going to be able to be exploited by an attacker. For that reason, the hypervisor, like we do with all other applications, needs to be hardened. We disable all unnecessary services. We patch the hypervisor, keeping it up to date with the security patches put out then by the vendors. Make sure it's adequately secured. We should also very strictly limit who has access to the hypervisor. Control and monitor anyone who's trying to make changes then at the hypervisor level. E-commerce. Certainly one of the things that's changed in our world in the last few decades is the buying and selling of goods and provisioning of services online, often, for example, through the internet. There's a number of different types of e-commerce implementations as well. For example, business to consumer, which we are all quite familiar with, where a company now sells a product to us directly as a consumer. Or business to business, where businesses themselves are exchanging then services at a business level. We also have a number of implementations between business and government, where again, government is availing itself of services and business is availing itself of government services through these types of e-commerce implementations. We also have then the relationship between businesses and their employees, where very often the employees are able to interact and to do e-commerce transactions with their employer. There are several different types of e-commerce architectures as well. The most basic and probably least trusted would be a single-tier architecture. The challenge then is you have an application running on a single machine, and anything that is done, of course, well, can easily be compromised, And in many cases, the problem with this type of single tier is it's rather inflexible. So instead, we've come up with multi-tiered types of architectures. For example, a two-tiered architecture, like we've seen for the last few decades, is a client-server relationship. We have a host server that supports then a number of different clients. We then have also the idea of a three-tiered architecture. With a three-tiered architecture, we have the application that supports then the client, and that's what we often call the presentation layer. Because the purpose of the presentation layer is to create a nice looking, aesthetically pleasing, easy to use interface for the user. Underneath the application layer, we have then the business logic layer. This is where we're actually doing all of the logic that is used to prepare the data for presentation at the application level. And then underneath that, we have that third tier, where the data is actually being stored. So we see that anything that a user does through the application goes through all of the logic necessary so it gets stored correctly at the data layer. This often allows us as well to bring in several different data sources, bring them together logically, so even though they're on several different machines in different underlying systems at the data layer, at the logic layer, we can bring them together so at the application, it looks as if it's just one application for the sake of the user. The risks associated with e-commerce then, well, obviously confidentiality. If I'm going to send sensitive data such as a credit card over an insecure network, there's very much the chance that credit card number could be then stolen or captured by someone who is eavesdropping on the line as that was communicated. We also have the risk here of integrity, where we have unauthorized alterations of the data, where someone is able, whether through a man-in-the-middle attack or maybe through improper access control mechanisms, can get in and actually change then the data. We've seen this with customers changing prices. We've seen in some cases where a person has been able to get in and actually corrupt then everything from the delivery address to the quantity of an order as well. Many of our companies today do an extreme amount, in some cases even 100% of their business, through e-commerce. That means if their networks go down or their servers are unavailable, their entire business is then handicapped, or really they're out of business for that time period. This is where we have to ensure that our systems are built with a level of redundancy and resilience so that a failure of any one component, a system or a failure of a network, will not then impact the organization. It can continue to operate. Another risk in an e-commerce world is authentication. If I accept a credit card from a customer, how do I know that that credit card truly belongs to that customer? If a customer can set up a user ID on my system, how do I know that they're setting up a user ID under their correct name? If a person places an order, how do I know that it truly was placed by that person, not by somebody else? It's almost similar in many ways to a problem we used to have if you delivered pizzas. All of a sudden, a person would get a phone call at the pizza shop ordering a pizza, and when we went to deliver it, find out that that person had never ordered one. This is the sort of problem we can easily have. The problem here of non-repudiation. If a person has ordered something from me, can they then later turn around and say, no, I didn't order that? How do we establish that that truly did come from that person so we don't end up manufacturing and delivering a product that nobody wanted? What this also has done has meant that we've moved a lot of our functionality out to the client's browser. When the client's browser is managing a lot of the input validation and error handling, that means that they could also potentially bypass security controls. We need to ensure that we build in security controls both at a client level as well as at our server level. so that a person cannot just bypass the validation we've put in and corrupt our systems. So what are the security requirements then for e-commerce? Well, we have to have firewalls. The purpose of a firewall, as we know, is to protect traffic going from one network to another. Protect our systems from being attacked, for example. We need high levels of availability. This means often having things like network resilience, redundancy, failover capability, and in some cases even load balancing. We'll have multiple network connections, and if one of those is overloaded, it can share its traffic then with another network connection. It is important that we protect the confidentiality of data we transmit through a network through things like encryption. And we can also then provide non-repudiation through digital signatures. We know that networks today are much better than they used to be. It used to be that many of the problems we had were because of noise on the line, and we needed to use parity bits and checksums to try to ensure that data had not been contaminated as it was transmitted. But today's networks are pretty good. We don't get a lot of errors because of noise, but certainly we still have that problem always of input and output validation. How do I make sure that that data that was sent to me was actually correct? And this is where we validate the format of our information. We validate the acceptable ranges. For example, we look at things such as the date, or we look at an acceptable price, or we look in many cases that does a postal code or a zip code match with the address we are provided. We also validate that the output we send out is accurate and certainly going to the right person. It is important that we have logs. We know what happened on the system, and these logs should include transactions or which purchases have customers made, but also should include any types of changes to configurations or then the structure then of our email architecture. We want to provide authentication. If a person is going to do e-commerce with their bank, online banking, we want to make sure that they truly went to their bank, not to a hacker posing as their bank. This is where we can validate that through certificates. We can have authentication. We are talking to that bank through the issuance of a certificate that says, if you use this public key, you will be talking to the correct bank. And that, of course, is validated through a certificate authority, such as, for example, Symantec, who bought this service off of VeriSign, Entrust, and a number of other certificate authorities that are out there.